Hi, welcome to Codevo, and in this episode of a Blind 75 series, we are going to solve this question called maximum subarray. And there are multiple ways to solve this question. The approach that we are going to see now is called Katan Algorithm. Let me just go over the other approaches that you might use to solve this as well. The brute force approach that you might think of is, it would be probably order of n cube, right? You would be having a nested loop to iterate through all possible subarrays of this array, and you would have another loop to compute the sum of all these subarrays that you're going to find. Okay, so in that case, you have a nested loop that is going to cost you order of n squared time, and you have an array, and you have another loop to calculate the sum, so that's order of n squared times order of n, that's going to be order of n cube, which is not that efficient. So maybe to optimize that, you might be using dynamic programming. And dynamic programming, again, you're going to have a matrix, and you're going to find all the sum of all the subarrays, right? We'll be using other sums to find your current sum, so it would be like order of n squared anyways, and that is not that efficient as well. That is a even more easier approach, even more efficient approach to solve this problem, and that is called Katan algorithm. It's a fascinating algorithm. It's quite elegant, it's very simple to understand, and very easy to code as well, but it's not something that comes to you intuitively. You will not be able to think of it easily. It's not an easy approach. I mean, it's fairly easy to understand, but you would not be able to come up with it intuitively. So if you watch this video, it will be fine by you. So let's check that right now. So what I'm going to do is I'm going to have a couple of variables. Those are going to be current sum and max sum. The initial value that I'm going to have in my current sum is 0, and the initial value for my max sum is going to be negative infinity. Now I'm going to traverse through this given array, and I'm going to do a couple of operations. What I'm going to do are, I'm going to add this current value with my current sum. So this is going to be, let's just say this is our nums array. Okay, I'm going to add this nums of I to my current sum. Okay, so that's going to be minus 2 plus 0, and minus 2 plus 0, I'm going to compare this with my nums of I. Is it less than my nums of I? In this case, my nums of I is minus 2. It's not less than my nums of I. So what I'd be doing is, I'd be adding that minus 2 here as well. So my current sum becomes minus 2. And for every iteration, you're going to update your max sum as well. And update in the sense, it's just going to check if your current sum is greater than your max sum. In that case, it would be updated. And since minus 2 is greater than minus infinity, your max sum becomes minus 2 right now. Now, I know you might not have got the entire thing right now, but wait for a couple of more iterations, you will be getting the concept. If not, in program you will be finding it very easy, so just hang in there. Moving to the next iteration, it's 1, right? So what you're going to do, you're going to add this 1 to your current sum, minus 2 plus 1, and minus 2 plus 1 gives you minus 1. And when you compare that with nums of I in this case is 1. Is minus 1 less than 1? Yes, minus 1 is less than 1. In that case, you would not be adding that to your current sum. Instead, you would replace your current sum with nums of I. You have replaced your current sum with your nums of I. Why are we doing this? Instead of adding minus 1 and minus 2 and 1, that is going to result you with minus 1. That is not a large number, right? Instead, you are better off just having this 1 alone. If you add with this minus 2, you are just going to decrease your 1's value. So it would be disregarding that and just take this 1 as your current sum. Moving on to the next iteration. I hope you have got some idea. This is what we are going to do. Let me go over the entire array so that you get a better idea, and then we'll move on to coding. Now we have minus 3, right? So this minus 3, you are going to add that with your current sum. Minus 3 plus 1, that gives you minus 2. Now this minus 2 is your minus 2 less than your nums of I. Your nums of I is minus 3. Minus 2 less than nums of I? No. In that case, you can update your current sum. So what you are going to do, you are going to update your current sum as minus 2. And I have missed one thing. In the previous iteration, we had our current sum as 1, right? In that case, I should have updated my max sum as 1. Okay, for every iteration you should be updating your max sum. I forgot it, please don't forget that. you should be updating your maximum for every iteration. So minus 2, now again you're going to compare it with your maximum. Since minus 2 is not greater than your maximum, you will not be updating that. Moving over to the next iteration, we have 4 here, and this 4, when you add that with your current sum, which is minus 2, that is going to give you plus 2, right? This is not clear, let me write that again. 4 minus 2 is going to give you 2, and 2, it's not greater than your nums of I. Nums of I in this case is 4, it's not great. So what you're going to do is you're going to delete the value that you have in your current sum, and you're going to place this 4, which is your nums of I, into your current sum, which is 4. Okay, now this, after this iteration, you're going to update your maximum. So 4, is it greater than 1? It's of course greater than 1. So you're going to update your maximum. That becomes 4. Moving over to the next iteration. In the next iteration, you have minus 1. You're going to add this minus 1 with your current sum. That gives you plus 3, right? Is 3 greater than minus 1? It's greater than minus 1. So you would be just adding this minus 1 here. So that gives you 3 in your current sum. Moving to the next iteration. In the next iteration, you have 2. Now if you add 3 and 2, that gives you 5. Is 5 greater than your nums of I? Of course yes. So you'll be adding this 2 as well. So this current sum becomes 5, and you're going to update your max sum. Your max sum is now 5, because 5 is greater than 4. You are updating your max sum. For every iteration, every single iteration, you're going to update your max sum. Now when you code this, it will be easy for you to get that. Okay, moving over to the next iteration. In the next iteration, you have 1. If you add 1 with your 5, that is going to give you 6, and 6 is of course greater than 1. So you'll be updating your current sum. Your current sum now becomes 6, and you're going to compare that with your max sum, and your max sum is smaller than your current sum. So you'll be updating your max sum as your current sum. Moving over to the next iteration. In the next iteration, you have minus 5. If you add your minus 5 with 6, that is going to give you a plus 1. Okay, is 1 greater than minus 5? Yes. So you are going to add this minus 5 to your current sum. That gives you 1. Now 1, you are going to compare it with your max sum. It's not greater. So you'll just ignore it and move to next iteration. Okay, since we have this max sum, which always has the maximum sum so far, you don't worry about your current sum being less than your previous value. Okay, that comparing it with your previous value, max sum takes care of that. Your current sum doesn't really have to worry about that. Okay, now we are currently at 4. 4, when you add with your current sum, that gives you 5. Is 5 less than nums of I? No. 5 is greater than nums of I. In that case, you would be adding that your current sum. So your current sum now becomes 5. You're comparing that with your max sum. Since your max sum is already greater, you would not be worrying about that. That's done. Okay, so this is what the approaches, and your answer, your maximum subarray sum is going to be 6, and that is what you will be returning as well. So I hope you got that. Now we'll go over to Leetcode and try to program this. It's a fairly easy solution to implement over there now. So as discussed in the explanation, we are going to have a couple of variables. So the first variable is going to be your current sum. Current sum initial value is going to be 0, and your max sum is going to have negative infinity. So minus INF, right? I hope it's right. Okay, now we are going to iterate through this nums list. So for I in nums, what I'm going to do is I'm going to add this I with my current sum, and I'm going to see if it's less than my I. So if I plus current sum, if it's less than my I, in that case I would assign my current sum as I. If not, I would be adding this to my current sum. So current sum plus is equal to I. Okay, so that is done. Now for every iteration, you are going to check if your current sum is greater than your max sum. That's going to be updated for every iteration, right? So if current sum is greater than max sum, in that case max sum is equal to current sum. That is it. At the end, you are just going to return your max sum. The implementation itself is fairly easy. Okay, so what you are going to do, you are going to take a number, you are going to add that your current sum, you are going to see if your current sum plus your current number, is it less than your current number? In that case, you would be just having your current number as your current sum. If not, you would be adding that your current sum. Just the same logic that we discussed there. And either way, you're going to update your maximum. You're going to see if your current sum is greater than your maximum. In that case, you're going to update your maximum. So that is it. You're going to return your maximum at the end, and I'm going to try to compile this and see if this works. So base test cases are all done. I'm going to submit this code. Okay, it has been accepted and it's quite fairly fast. So that is Katan's algorithm. It's fairly simple and straightforward. I hope you understood the logic, and the coding actually it's very simple, as you saw. So that is it. If you have any questions, please put them in the comments, and if you have any suggestion for me to solve the next question, put them in the comments as well. See you in the next video. Bye for now.